Divide two rational functions with the resulting answer containing a remainder. Okay, here I have a rational function, and I'm asked to divide the two rational functions with the resulting remainder. First of all, I know it can be divided because the degree of the function up top is higher than the degree of the function down below, therefore the bottom can go into the top. First, what I need to do is I need to find out how I can rewrite that x to the 6 in terms of what's in the denominator. So essentially what I'm really asking for is I have x to the 6. I need to rewrite it in terms of x squared plus 2x plus 5, so I may pull it out. And this can be done. The trick is to ask yourself, well, what do I have to multiply this particular function by in order to get back to x6? Well, I know I have to multiply it by at least an x to the 4th. And now when I distribute it through, I get x to the 6th, but as a result, I also have an extra plus a 2x to the 5th and a 5x to the 4th. So I have these additional terms. These additional terms I need to account for. Because I just want a resulting, I need to get back to just an x to the 6th, so I need to find a way to get rid of them. The way I can get rid of them is by taking them out. Taking out a 2x to the 5th minus a 5x to the 4th. Now when I look at this whole exact term right here, when I rewrite it, distribute it through, that simply rewrites it down, gets me back to an x to the 6th, but I am also in terms of what's in the denominator. And the reason that is important is now I can rewrite the rational function such as this. So now my rational function is now be rewritten in terms of this. And as you can see, this green term here is nothing more, this whole entire green term is nothing more than x to the 6th. But the reason I rewrite it is now I have the common denominator of x squared plus 2x plus 5, which is what's in the denominator, so I'm able to cancel out. Before I go to cancel them out, I also look at what I have here, my new terms I've added, and see if I can combine anything, any like terms. And in this case, I don't have any like terms on the right side, so now I just go into reduction. So now I can be rewritten into these equations. Simply by simplification, reduction, I can get into that. And you can see here I have, when I separate the two fractions, I have a common denominator, so I can cancel them out. So I'm left with an x to the 4th minus this term over here. And now, as you can see, I look at the degree. Here I have a degree of 5, and here I have a degree of 2, so again I can do the same procedure. Only this time I need to rewrite simply a negative 2x to the 5th. I need to have it in terms of, again, the denominator down below, in terms of how can I rewrite that in terms of x squared plus 2x plus 5. And I go through the same procedure. What do I have to multiply this guy by in order to get the same term back? So I know I have to multiply by at least a negative 2x to the 3rd. But going through there, when I go through it, I realize again, I get my negative 2x, I have some additional terms. In this case, it ends up being a negative 4x to the 4th and a negative 10x cubed. So I have some additional terms, and I got to make sure that I compensate for them. The way I compensate them is make sure that I can take them out by adding an equal and opposite operation. So now my new term up top is as follows. And so now my new term is in this format. But before I cancel out or simplify it anymore, I first look for like terms, and I see I have like terms. I have like terms with these two guys, so I can add those, combine those two into making a 13x cubed. And then obviously then I can pull out this negative 2x cubed and cancel out that x squared. So my next term looks like this. After canceling like terms, and after combining like terms and canceling, I end up with this. And as you can see, my degree up here is 4, and I'm 2 down here, so I can keep on going. And after I keep on repeating this procedure until my degree up top is smaller than my degree down below, that's when I stop, and whatever's left over, that's going to be my remainder. After several iterations, you get them up with this. Now you notice that the degree up top is lower than the degree down below. Therefore, this entire term is considered your remainder, and this will be your final answer. And all it is basically division of two polynomials.